Yeah, come on everyone. Let's see how to do this. Now, for this wave here, the potential energy would be integral of tension dx dou y by dou x ka whole square. This will go from 0 to lambda by 2. This is the potential energy of a loop, but I think first let's do for a segment. And we know here y is equal to 2a sine kx cos omega t. It's a partial differentiation of tension is mu into v square into dx. And this would be 2a k sine becomes cos kx. Cos will remain cos omega t only. Ka square. And v square k square would be 2, so that will be 4 2 mu a square. V square k square will be omega square. We have done something similar there. Dx cos square kx cos square omega t. So if you see every segment, right, has the potential energy changing with both position and time. Same thing if you do kinetic energy. This would be half mu dx, that is half dmv square. This would be how to differentiate this guy cos omega t. This will be 2a omega sine kx sine omega t. Unlike progressive wave, here they are not equal. If you remember in a progressive wave, they used to be equal. So 2 mu a square omega square dx sine square x sine square omega t. This is the kinetic energy of a segment. Now, if you take total energy of a segment, we end up with 2 mu a square omega square dx cos square kx cos square omega t sine square kx sine square omega t. This is not constant. Every segment ka energy is changing. Even though they're executing SHM, the energy is being transferred from left to right. If you remember, this is what I said even in a progressive wave. When we calculated the energy, think about it here. Here, these particles are oscillating SHM only, na? It doesn't mean energy of a system is constant. The energy is continuously flowing. Whatever energy you're losing, you're getting from the other side. If you see here, the total energy of each segment here was not constant. It's changing the time. In an SHM, the total energy is constant for a particle. Clear? Here, they are executing SHM, but the energy is not conserved. Because simple reason also, if you think of like this, each particle is connected by a string on both the sides, right? There are external forces on the system. So this is the total energy of a segment. So direct substitution there. Now, if you want the total loop, so this is one thing to do. Now, if you want to get this thing, I need to integrate this with the total energy of the loop as a function of time. So I need to integrate with x. Total energy of the loop will be integral te dx from 0 to lambda by 2. There's actually a much faster way. And you integrate this. Now, omega time ka thing is constant. So this will be 2 mu a square omega square dx cos square omega t. This will be cos square x dx from 0 to lambda by 2. plus 2 mu a square omega square dx integral sine square kx dx from 0 to lambda by 2.
Sir, how did you get one dx outside?
I don't get it. नहीं अंदर होगा. ना cos square kx का इंटीग्रल कैसा करेंगे? 1 minus 1 plus cos kx by 2. ठीक है? So 1 plus cos 2kx by 2. When you integrate this guy would be lambda by 2 plus cos 2kx में k is 2 pi by lambda, and when you substitute lambda by 2, this will cancel. That will become cos 2 pi anyway, which is 0. तो second term चला जाएगा दोनों cases में. So I'm directly doing it. You can verify. This guy will turn out to be lambda by 2.
So
This guy
cos 2
also
pi,
turns out to be, अरे
cos 2 pi is 1, no?
cos 2 pi cos 0 1 na 1 plus let me solve. Loop 1 plus cos 2 kx. नहीं उसको इंटीग्रेट करने के बाद sin 2 kx होगा ना.
अच्छा ओके हाँ ठीक है.
Then we keep lambda by 2 0 हो रहा है. So
हाँ
this
yes.
guy would be lambda by 4 and this guy would be lambda by 4. You can check it out on your own. And then this thing turns out to be 2 mu a square omega square lambda by 4. Now interestingly, cos square omega t plus sin square omega t will be stuck, come out. I forgot to write here. This turns out to be half mu a square omega square lambda. That is the total energy of a single loop. Clear? This is how we integrate this. But there's much better way. Listen, alternate. Let's try to understand what is this loop exactly. How are you getting this? So this thing is nothing but two waves are entering, isn't it? This is wave 2 and this is wave 1. Both are entering from both the sides. So both are giving you how much power? So power is entering from this side, which is half mu a square omega square v wave. This also the same power is entering. Half mu a square omega square v wave. So this much power is entering from both the sides. So how much time will it take for this power to go from this point to this point? So whatever is the time, so this distance was lambda by 2. So the time taken or the time interval for which the power is being pushed inside from node to node will be lambda by 2 wave. Do you agree with that? Meaning whatever energy is entering this node from this side will leave this node, meaning within that loop for this much time the power is entering inside. So how much energy are you pushing into the loop? So total energy of the loop will be power into time, and you're doing it from both the sides, so into 2. So this guy would be half mu a square omega square v wave lambda by 2v into 2. V will cancel, this will cancel. Half mu a square omega square lambda. Half mu a square omega square lambda. This is faster. Since nothing but wave is nothing but a transfer of energy, how much energy are you transferring into the loop? This much energy you're transferring for this much time. So power into time from both the sides, you're done. ये सब करने का जरूरत नहीं था. But this was important to prove that the total energy of a loop is not constant. For a segment is not constant, but loop becomes constant. Have a look at this. Let's study it a little, with pictures and all also. Let's see that part. Any doubts on this and this integration? Please ask. So this was brute force maths. There's nothing there. Looks like some of you didn't fill the forms for July 7th. Right? What happened? You guys don't want to come. Food will be better. Nahin? We will make sure you get extra 2 gulab jamuns also if you come. You can't carry home, but I have the list people who didn't this thing. I will check it out. So if you have forgotten, please fill up the form. If there's a genuine reason, just fill up the form and write there. Like, sir, I'm on diet. I can't eat too many sweets. You can write down. I don't mind. Do try to come because everyone is coming. Arav is coming. Even the girl students are coming. So nothing much because next 6 months it will be stressful. Better you talk to someone, understand what they went through. So up to you. Meaning I'll not be forcing you guys, but if you're free, if you think like, yeah, I know Sundays sometimes you have exams also, but it's just a one evening, so plan it out. Clear with this? Now let's try to study this thing quantitatively. So this is what we got mathematics, this thing, maths and all. Now if you try to study here, you'll find pretty interesting points. Or maybe some of you are not coming because it's the same place as last time. Don't worry, next time I will take you to a different place. You are the only batch which will get invited 3 times. Normally in 11th, I don't call. I call only in 12th and when you're passing out. But some of you actually came last year also. So yeah, that time you all were small, chota kids type. That's what let's call everyone. I hope everyone still are the same or you became too tall. Nobody. On my screen, everyone looks this much only. So I feel always you are small kids. I don't know why. Small kids, in my imagination, all of you are in first standard or second standard. That is a kind of, not Ishan, but most of you, I think so. ईशान को देख के लगता है यार ये तो मैं कॉलेज प्रोफेसर है. Meaning, not in terms of that, but like seriousness and all. So, meaning I'm praising you रे IIT का प्रोफेसर से कंपेयर कर रहा हूँ God.
सर बेनिफिट्स वो तो बंदे दो स्टूडेंट प्रोफेसर नहीं देखते.
चलो. So, if you look at this dotted line, this was your natural length. Now, same logic that we applied here. If you look at the topmost point here, if you take a small segment here, this was the natural length. This was also the same length. The elongation is always 0. You will find more interesting points on a progressive wave here. If you look at this thing, the potential energy of this topmost point is 0, always 0. Even when it comes down, it is flat. When it is at the top, it is flat. It will always be flat. Whereas the kinetic energy at the topmost point is again 0 because it's at the extreme position. That same segment, so potential energy dx for small segmented antinode is always 0. Because no matter how much it oscillates, that segment will always remain flat only. Same thing. If you look at this segment here, this was dx. And if you look at this thing here, this thing is maximum stretched. And if you look at this point here, kinetic energy at the node dx is always 0. Why? The point at the node never moves. The potential energy can change. And potential energy here is max. So kinetic energy and dx at the node is always 0. And you can see from clearly here, the total energy of a segment is not constant. Now, why I'm writing this specifically now? Because in all books and everywhere, people write total energy of a loop is constant. Which is right. But the moment in the exam, they'll ask you total energy of a segment. And the only thing you remember is someone told it is constant. So you will just write constant and come without understanding. Are you talking about a segment or this thing? Just like remember, If you put a dipole inside a Gaussian surface, what is the total flux? Zero, because total charge is zero. But what is the flux at every segment? It can be zero, positive, negative. It can be anything. Remember that? So that way, flux at a point and flux on the whole surface is completely different. Same way, energy of a loop and energy of a segment is different. Is this page clear, everyone? Now that means when you look at this, turn in the page. So when this loop is there, so this is your nodes. This is the node. So when the string is extremely, in the extreme position, this is what you'll notice. Now see, and this antinode here, the potential energy is zero, kinetic energy is zero. So there is no energy here. Fair enough? At this point here, potential energy is max, kinetic energy is zero. At this point also, potential energy, again, we are writing for a segment. This is all for segments. Kinetic energy is zero. Now, when this string comes down and becomes flat, remember this thing, the entire string is oscillating up and down. When the string becomes flat, now this is still the node. This is the node. This is the anti-node. You will notice something. This guy ka potential energy became zero. Kinetic energy anyway is zero. Means the nodes lost all the energy. Here also, the potential energy is zero. The kinetic energy is zero. It lost all the energy. At the center, the potential energy is anyway zero, but now the kinetic energy is maximum. Means what happened? While the string is coming down in this process, so from the extreme position, when you come from extreme to mean, the nodes are losing energy. Energy transfers like this. Energy moves from nodes to antinodes within the loop. So there is an energy transfer from both the sides. You're getting it? So energy is transferring from the nodes, they are losing energy, and the antinode is gaining energy. Now from this position, again, when you go back, from again mean to extreme, the string will go back to the other position. Maybe I'll try to draw that also. So when the string again becomes like this, so from here to here, again from mean to extreme, this will be a theoretical question in the exam. So in a stationary wave, how is the energy flow within the loop? Now from here, the energy is flowing from antinodes to nodes, it is going back. You're getting it? So energy is continuously being transferred to and fro. That way. Have a look at this. Just give me a minute. Yeah. How is energy constant in the loop? Let's see that thing. So if you see here, so the energy is continuously moving here. So let me put it down. So when string moves from extreme to mean, right? Energy transfers from node to antinode, and vice versa. Second point, energy never crosses the antinode. Means whatever energy coming from here, this will not cross the antinode and go this side. By symmetry, both are transferring energy, isn't it? Whatever happens on the right, the same thing happens on the left. So that energy transfer is also only exactly within half of the loop. There is no energy will not cross the antinode, because the only way energy can cross the antinode is through elongation. That guy will never have an elongation. Energy never crosses the antinode. Within the loop, energy is redistributed. Total is constant, but within the loop, every point is not same. The energy never crosses the node. Now that we can explain in a much easier way. That we can explain from here. This part, if you see here, look at this node here. Now you said two waves are coming, isn't it? So at this point at the node, this side the power P is traveling, this side the power P is traveling. So the net energy transfer at the node is how much? Zero, isn't it? Whatever is coming from the left, the same thing going in the right. That means the total energy within the loop is constant. We proved this thing here. Make sense, I know? If you say energy of the loop is not constant, that means energy is coming out of the loop. So the energy of the loop should have been changing. Clear? So the simple reason is energy is entering and leaving, and this works because both have same amplitude and same frequency. If the waves had different amplitude, now this will be 4p, this will be 2p, something like that. That means node won't be at rest. Node also will start moving, and then you don't call it a node anymore. Please have a look at this page. Quite an important one. This is how it will be more than one choice with theoretical questions. Especially the energy redistribution into the loop, that is a little weird. Because everyone talks about full loop only. I'll do one thing. Let me show the full loop, okay? I'll come back to that page. If you have taken energy of the loop, this is what you'll notice. The potential energy of the loop, okay? We are taking full loop is maximum. Why? It is maximum elongated. So when you take the full rope compared to that initial length, it is maximum elongation. The kinetic energy of the loop is zero. Why? All are at extreme position. So when the same loop comes to the natural length or the mean position, at this stage, the potential energy of the loop is zero because everyone is at natural length. Whereas kinetic energy, the loop is maximum because all are at mean position. They're going at maximum speed. So the total energy of a loop is constant. I hope that is clear. But within that loop, a lot of things are happening. Please have a look at this thing page, step by step. Any statement that you didn't understand or not clear, please ask. This I'm showing you everything with pictures. Mathematically, the proof was this. Where literally we proved the energy of each segment changing with position and time. Meaning you see now, whenever it is a node, right, these terms will be potential energy received. If you take a node, right, node may, I think anti-node may, this term will be always zero, cos 90. Isn't it? That cos square x will be zero for an anti-node. And for a node, the sine square kx will be always zero. You are fixing up the position. Check this out. There, this is the analysis of that thing. So energy of a loop is constant. Any doubts on this? This is something they never asked before, so it's a good one. But can I go ahead? Now, going more, you have seen this somewhere else also in an application. You will get the PDF, right? No need to write each and every statement. Just try to absorb. Last time I said like that only absorb someone and someone started sleeping. So don't absorb so much. This thing, no? Now you have seen this, where a few things here. If you remember, de Broglie wavelength, lambda de Broglie is what h by mv. Don't know this thing? Chemistry may somewhere you studied, right? De Broglie wavelength. Now, if you remember the Bohr's theory, Bohr's atomic model. So we have the nucleus here, and we have the electrons going in an orbit. And we have a statement there, the angular momentum is quantized. mvr is equal to nh by 2 pi. Now, how did we get this thing actually? So if you look at this, if I adjust this, we get 2 pi r is equal to nh by mv. So we can write the circumference 2 pi r is equal to n times lambda. That means when you take n is equal to 1 or n is equal to whatever number it is, you are treating this thing to be a stationary wave. The electron is forming a stationary wave. I didn't draw it properly, but something of this sort. Getting it? So the electron, the orbit of an electron forms a stationary wave. So actually angular momentum is constant came from there. Now there is a property for a stationary wave. What is that? Energy is constant. And that was the drawback of the Rutherford model. Remember? If an electron goes in a planetary model, the electrons will be accelerating and they lose energy and they collapse. But there are some specific orbits. If you go in that orbit, your energy won't be lost. That was a statement of the Bohr's theory. That reason why the energy was not lost is because these electrons form stationary waves for that specific orbit. And that is the reason energy is constant. And that's why the orbit name is called stationary orbits. That is how the name comes, stationary orbits. So that is how actually reverse means stationary orbits. This guy proved angular momentum is quantized. You can say like that. More of an experimental thing, but we can prove it like that. So stationary wave, and therefore energy of an electron in this orbit remains constant. So n is nothing but the harmonics here. De Broglie came later on. The Bohr couldn't explain why is this, but he knows from experiments, I suppose. But later on we could prove it. But in this orbit is constant. Meaning, like I said, after everything is done, we'll be able to connect the dots from back. So stationary wave, angular momentum, and electron. I'm sure you must have never thought something of connection could be like that. Energy of a stationary wave came from there. All clear with this? Great. The next thing. Turn in the page. So there, that is about energy of a stationary wave. General equation of a stationary wave. So y is equal to 2a sine kx plus phi 1 sine omega t plus phi 2. So this phi 1 tells you the position of origin. This phi 2 tells you position of string at t is 0. Let me show you what it means. So when you take your standard equation, which we are using till now, y is equal to 2a sine kx cos omega t. Look at this thing. At x is equal to 0, we have origin. So in this case, we assumed we have taken x is equal to 0 is origin. And when time is 0, cos is maximum. And second point, we are taking a scenario at t0, the string is at extreme position. Meaning this is what you did. So you have chosen the node as an origin. So x is equal to 0, sorry, x is equal to 0 is a node. So you have taken x is equal to 0, the node as an origin. And at t is equal to 0, you have taken all the points are at extreme position. Making sense? So when the string is oscillating, at this instant, when you started watching your motion, this equation belongs to this one. Next one. Can you tell me how will this guy look like? Y is equal to 2a cos kx sine omega t. We can reverse this also. Here, what did you do? सिर्फ देख लेना ये amplitude है. If I keep x is equal to 0, what am I getting? I'm getting maximum. So we have chosen x is equal to 0 as antinode. And at t0, all are at 0, meaning at t0, string is at mean position. So this point has chosen as 0 antinode. L by 2. I'm taking fundamental only, yeah? One loop I'm taking. And if you look at the speeds here, this guy is the maximum. So the strings all are having maximum speed. So the string is flat. So if I take y is equal to 2a sine kx sine omega t. So here, same thing, the string is flat, but this time you have taken x is equal to 0 as node, and the string is at mean position. So second and third example, the only difference is the origin changed. If you take y is equal to 2a cos kx cos omega t. So all these are stationary waves. Just because I made one sine and cos, don't think it's a different thing. Meaning t0, string is at extreme, and we have chosen the antinode as origin. Is this clear, everyone? Clear? Let's see a question. So I will give you a function. You tell me how is the wave. Y is equal to 2a sine kx plus 2 pi by 3 sine omega t plus 7 pi by 4. So can you tell me how will the string looking at t0? Let's take fundamental loop. Okay, one loop we can take. And if I know one loop, I can replicate the other one on the other side. So no, that is not required anymore. We'll just take one loop. Try. Take a minute. Origin. Okay. Let's see. That looks right. So first thing here, let's find the node. So for node, directly you can take kx plus 2 pi by 3 equal to 0. We get 2 pi by lambda, x is equal to minus 2 pi by 3. So x is equal to minus lambda by 3. That means on the string, you have taken the node. So this was the node. The node is at x is equal to minus lambda by 3. Origin is somewhere here. Remember, the total distance will be lambda by 2. So this is lambda by 6. Is that making sense? The distance between two nodes should be lambda by 2. So we have chosen origin somewhere. So from the origin, the node is lambda by 3 backwards. And the other node will be lambda by 6 forward. The total distance should be lambda by 2. I hope that was clear. So this distance is lambda by 2. And here, now this is literally SHM. 7 pi by 4 means how is the particle oscillating? X is equal to 0, x is equal to plus a, x is equal to minus a. 7 pi by 4 meaning you went up, you came back, then you came back, and then you're going up. So the particle is at x is equal to minus a by 2 and it is going up. Meaning the string is like
minus
this.
a by root 2 होगा ना?
A by root 2 था. A by root 2. That means the string would look like this would have been the extreme position, the red line. This would be the string and all these particles are going up. So this distance would be amplitude, my central maximum is 2a by root 2. You're getting every point by root 2. And all these points are traveling upward. Make sense? So the string is in the lower quadrant at a by root 2, amplitude by root 2, and then it is going up towards the mean position. Clear with the equation? So there, I gave you the equation, you found the path. Now let's do the reverse. I'll give you a situation, you have to find the path. You have to find the equation. Clear with this? Great. So before that, let's do a question. And then we will find the equation also. What if this side is not a fixed end, but a ring? Length of the string is L. So find the harmonics for this. Find the frequencies which stationary waves form. That is the first one, standard question. Then, so till now we are playing with the fixed end, right? Now we are changing it. And let's say this point is x is equal to 9/4 meters. And this point is x is equal to, I'll do one thing. Let's finish off this and then I'll give you this again better. Let's not confuse you. First, find the general wave equation, meaning you can assume this is a node and that's x is equal to 0 here and solve. Find the frequencies, meaning remember sonometer mein I derived it for this thing, general equation. I want you to find something like this. Like this. I want you to find a frequency like this for nth harmonic. I hope you remember the derivation, how we did first possibility, second possibility, same story. Try, you got 2-3 minutes. Mass of the string ले लेना, mu ले लेना. Same story. Now, if you look at the first possibility here, now understand the free end has to be always an antinode. Why? Logic, देखो now. When the wave is getting reflected here, this is the incident wave, this is the reflected wave. So this is A, this is A. Shouldn't this amplitude be 2A then? And isn't that the definition of an antinode that will go to maximum 2A times amplitude? So when the wave overlaps with itself, the wave ka this thing will jump here. We have done this here before, see. In this question, did you see when we did an open end, this guy ka amplitude became double. The incident wave and the reflected wave overlapped with each other. It became A plus A 2A. So that free end has to be an antinode. That is the first thing you need to know. So fixed ends are nodes, free ends are always antinodes. So the first possibility will be like this. So again, remember what is the meaning of this? These are different possibilities of the string. So the string is here at T1. Then the string comes here like this, T2. And then the string became flat. And then the string became like this. And then the string became like this. So basically, these are different positions of the string. It oscillates so fast, it looks like an half loop. And we know for an half loop, the distance is lambda by 4. So this is x is equal to 0. This is x is equal to L. So lambda by 4 is equal to L. So we get frequency will be V by 4L. This is your fundamental frequency of first harmonic. That's a definition. First harmonic is the first possibility. 4L आएगा रे. How does the second possibility look like? Have a look at this page. So this will be V by 4L. V by 2L is when both the ends are fixed. The second possibility we'll have one full loop and we have to have an half loop. You don't have an option. वो right side half loop होना ही चाहिए. So you will get here half loop, 1.5 loop, 2.5 loop, 3.5 loop, and so on. So this guy would be lambda by 2, and this would be lambda by 4. So we get 3 lambda by 4 is equal to L. So this frequency will turn out to be V by lambda. We get F3 is equal to 3V by 4L. This is your third harmonic. Now be careful, harmonics are not the consecutive numbers. 3 times the natural frequency, fundamental frequency is the harmonic. So this is third harmonic. And it is a first overtone. The first frequency after the fundamental is the first overtone. So here even harmonics are missing. 2, 4, 6 won't exist. If you go back to the definition of overtones, overtones are simply the frequencies after the first, second, third, and those are the overtones. But after the fundamental, directly you got the third harmonic. There is no second harmonic here. If you look at the third possibility, we have a loop, and we have an half loop. Same story, lambda by 2, lambda by 2, and lambda by 4. So we get 5 lambda by 4 is equal to L. So lambda is 4L by 5. So when you take frequency, you'll get F5 will be 5V by 4L. Basically 5 times F1. This is your fifth harmonic and second overtone. So you have to be really careful when there is an open end. They will say third overtone, and people will take fourth harmonic, you will get trapped. Third overtone is which harmonic? Third overtone. First overtone is 3, then 5 and 7. Seventh harmonic. This is a second overtone. So from here we can see the general function. So Fn will be 2n plus 1 b by 4l, where n starts from 0, 1, 2, 3, where n is overtones. Or 2n plus 1 is the harmonics. Or you can take 2n minus 1 and you can say n is equal to 1, but it depends. Basically, I just want an odd number here. This is the general formula for when the string is open end. Generally in lab and everything, we always study fixed end only, but this is also a possibility. Have a look at this. This is how you derive. I can even create a situation where both the ends are open ends. This thing, right? क्या difference पड़ेगा? The first harmonic will look like this, isn't it? So this will be lambda by 4, lambda 4. This is as good as both the sides fixed. This will be both the sides fixed. So both the ends will be antinodes. You'll get exact same formula when both the sides are fixed. So that is not actually nothing new. The diagram would look weird, but you will get that NV by 2L ka equation. All clear with this?
Still, I have a question.
बोलो ना.
वो जो fixed end है, it
Hmm.
has to be an antinode always. क्यों?
Yeah. है. Starting में क्या था वो story पूरा वही बताया मैंने. You didn't listen.
So it's a free end means it can move, but it does not have to move now. If we make it
है.
a node, क्या problem होगी?
अरे God. When a wave comes and hits the loop, क्या होगा?
It deflects
Let's say
back.
half of the wave is gone. Remaining half of the wave is like this.
Mhm.
अब इन दोनों का सुपरपोजिशन क्या होगा? टू वे ना.
Yes, sir.
तो टू वे which point goes to two way in a stationary wave?
Antinode.
So it has to be an antinode.
Okay, sir.
Because when that thing exactly symmetrical आएगा ना, half of loop तो overlap होगा ना two way. If you go at least once to two way, means you'll keep going to two way, right, as the waves keep coming.
So even if it is a node, it will
Node
like
तो move ही नहीं करेगा God.
yeah. So हाँ तो मत move करने दो ना मतलब
मतलब
issue
क्या
नहीं.
करना चाहिए? This thing and the reflected wave should be inverted.
हाँ.
अरे it's a superposition of two waves ना रे God.
अच्छा
In a
okay.
stationary wave, superposition of two waves.
Okay sir, I get your point. समझा.
इंसिडेंट एंड रिफ्लेक्टेड दोनों का होना चाहिए. अगर तेरा लॉजिक ना रिफ्लेक्टेड अगर इन्वर्टेड है, then they would have cancelled. This point would be a node always.
Hmm.
But here reflected is always being in phase na, with that incident. So they'll always add up.
Okay. Okay sir.
That guy will move. It can not move. When one possibility na, when there is no wave has not come, it will not move. But I never said antinode is always at two way. Antinode goes from minus two way to two way. तो बीच में एक बार जीरो टच करके जाएगा.
Okay.
I think maybe you're confused that. तुझे लग रहा है antinode मतलब always it will stay at two way. Did you think
हाँ I
something
kind
like
of thought
that?
that only.
नहीं, एंटीनोड मतलब ये नहीं, इट विल ऑलवेज बी एट टू वे. इट कैन गो टू टू वे टू माइनस टू वे. सो बीच में जीरो क्रॉस करेगा मल्टीपल टाइम्स.
Okay sir.
All
समझा.
clear with this?
Yes sir.
Now based on this, this is a 2 kg block. So mu here is 2 gram per meter. So mass of the string is very small, so you can neglect its own tension. This position here is x is equal to minus 1 by 4, and this position x is equal to 9 by 4. So this is a free end, and this is a second overtone. And particle ka maximum speed is 2 meters, 2 centimeters per second. There, with this data, find the equation of the stationary wave at t0. Find the equation of stationary wave at t0. I am giving you the initial condition. At t0, particles are at half of their amplitude. Meaning every particle is at half of its maximum position amplitude, and coming towards mean.
So even this can mean two equations now.
Yeah. So just to give you an idea, what I want you to find, 2a sine kx plus phi 1 sine omega t plus phi 2. So I am asking you to find the amplitude k, phi 1, omega, phi 2. If you can find these 5 things, my job's done. Remember, your amplitude is 2a. Total, the 2 term is an amplitude. It's a pretty good question, right? This combines the wave equation and the sonometer and the free and everything. Let's give it a try. Different particles are different max speed. So Vp max is this is the maximum speed of a particle on the string. So that will be the antinode. Now see, every particle has its own maximum speed. Among them, there's one guy with the maximum speed. That guy is an antinode. So this is antinode ka point. Generally, if you don't mention anything, that's what I will assume. The maximum particle, a maximum speed of a particle on the string. Phase is an interesting one. Phase is the easiest one. SHM pura वही story था. Isn't it? We spent almost like 20, half an hour, 20 minutes or more on that phase angle only. What is phase? What is phase? Let's see. You said second overtone. Which harmonic is this? Fifth. Fifth harmonic. Second overtone था वो. Fundamental frequency. See, you have 1, 3, 5, na? 1, 3, 5. So this is the first overtone. This is the second overtone. Meaning how many loops are there? 5 half loops are there. So the string would look like this. And you said that is x is equal to 1 by 4. So 5 lambda by 4 is 2 meters. Right. And from here I got lambda is equal to 5 lambda 2 by 4 9. Okay, add करना पड़ेगा ना 2.5 meters. Sorry, 2.5 meters. So lambda is 2 meters. That means when I took this position as x is equal to minus 1 by 4, this was x is equal to 0. Lambda by 4, na? So that is 2.25 and 1 to this guy would be how much? Lambda by 2. That means 1 meter. And this guy would be x is equal to 3 by 4. This guy would be x is equal to half. So x is equal to 0 will be somewhere here. Right? X is equal to 0 is not the antinode. ठीक है. This is the second overtone or 5 half loops. Fair enough. I got lambda from here. So if I got lambda, I'll get k ka value, 2 pi by lambda. That would be pi. K aa gaya. V wave is nothing but root over T by mu. Block is given here, 2 kg, so tension is 20. Mu is 2 gram per meter. Be careful, write in SI units. 1 gram is 2 into 10 power minus 3 gram per meter. So that would be 100 meters per second. And then we know V wave is omega by K. तो यहाँ से ओमेगा भी आ गया. And we know Vp max is 2a, that is a maximum amplitude omega, which is 2 centimeter per second. तो यहाँ से 2a भी आ गया. The main things are stuck with the phi 1 and phi 2. Now here, if you look at this, the amplitude is 2a sine kx plus phi 1. This is your amplitude. So basically at x is equal to minus 1 by 4, we need a node. So therefore, k into minus 1 by 4 plus phi 1 should be 0. It can be 0, it can be n pi, anything. We are taking the first, the simplest one. We are taking 0. So we get phi 1 is equal to k by 4. K is how much? Pi by 4. Clear with the phi 1? I have chosen that as an origin. You could have actually chosen this point as an origin, then this would be something else. But no, we have to take that only as origin. I gave the coordinate already. So that is the simplest pi by 4 there. You can always have multiples of the 2 pi, it's fine, but it works out. अभी क्या निकालना है? Phi 2 भी निकालना है. How do we get phi 2? At t0, your string is at half of the amplitude and coming towards mean. Now there's a problem here. There are two possibilities. When the particle is oscillating here, y is 0, y is equal to plus a, and y is equal to minus a. First possibility is you have gone to the extreme and you're coming this way. You're coming towards mean, half of the amplitude, meaning the phase angle phi 2 can be phi pi by 6. The second possibility you started here, you went up, you came down, and then you are going here. You are here at y is equal to minus a by 2, and you're going towards mean. This can be how much? 330 degrees, na? 360 minus pi by 6, 11 pi by 6. So phi 2 can be two answers. Because you didn't tell me whether the string is up or down, so I'll assume both the cases. Is this clear, everyone? There. This question is pretty good one, meaning you had everything in this. Wave equation, general wave equation, open-ended string, sonometer, wave speed, SHM, every damn thing is there. Please have a look at this. With this, we are done with waves on a string. So, like I said, there are two parts, waves on a string and sound waves. This is the first part of the waves. So we have done almost 29 questions. So I hope this part there is a clarity. If you understood all these stationary waves here, sound waves will go quite easy up to the stationary waves. And then we have beats and Doppler. Those are a little different. Clear? Next one. Going ahead, sound waves. Now, sound waves is basically we are studying longitudinal waves. And like I said in the beginning, we will limit our study only to sound waves. So in a sound waves, again, the same story. When you say y is equal to a sine kx plus minus omega t, what changes basically? So when sound propagates in a medium, basically it's a disturbance. So what are you changing when you propagate in a medium? When the sound propagates in a medium, the property that changes are change in pressure. This was a CET question. Huh? When a sound wave is propagating in a medium, which of the following quantities change? Options were pressure, change in pressure, something else they gave. It was change in pressure. It is not pressure. You'll see what it means. Yep. Yeah. So change in pressure, displacement. So displacement anyway changes, right? And then density. So these are the primary things. So if you want to study a sound wave, you can study in terms of displacement, pressure, or density also. So question was something like this: which of the following properties do not change something of that? So pressure is not the answer, change in pressure. But here we prefer to study in terms of pressure, because human ears, right, we are sensitive to pressure than displacements. It is preferable to study in terms of pressure. So the entire transverse wave we studied in terms of displacements. Here we will study everything in terms of pressure. Since humans and instruments, if you look at your mic or anything, right, these are pressure sensitive devices. Ever heard about piezoelectric materials? Quartz is a piezoelectric material, meaning when you take a piezoelectric material and if you apply pressure on it, every time the pressure is applied and removed, it generates a voltage. So when you're speaking in your mic now, what you're doing is there's a quartz crystal there. So when you're speaking, you're hitting it with waves. So whenever the wave hits, the pressure rises. When the wave goes, pressure decreases. So there is a frequency there. So your quartz crystal generates voltages. That voltage is amplified and transmitted through your signal. And the same way now, when I'm speaking, you're able to hear, the same thing happens. If I give electric signal to the quartz crystal, it starts vibrating. So the entire communication that we are doing, right, is because of piezoelectric sensors. So instruments detect pressure. So if you look at your eardrums, right, your eardrums also are based on pressure. What is the difference between frequency and intensity? What's the difference between frequency and intensity? Frequency, right, is the number of waves per second. So if you think in terms of your eardrum, this is what will happen. Let's say this is your eardrum. If I give a high frequency, it means the eardrum will oscillate much faster. If I give high intensity, means your eardrum will stretch maximum. You're getting it? Your eardrum will stretch maximum. That is intensity. High frequencies, eardrum will vibrate pretty fast. That's why when the frequency is high, you get irritated. Your eardrum is getting irritated, but it doesn't pain much. But if it's a high intensity, your eardrum can tear. Okay, it's like if I have to tell you, right, high frequency would look like this, tuck, 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 tuck. This is a high frequency. High intensity would like tuck, tuck. If I'm shouting loud, but this is a low frequency. Let me see if I can get something to irritate your ears. This should work. Able to hear? This is 440 hertz, right? And this is the volume, right? See, this is high intensity. This is low intensity. So when I'm changing the volume, it is intensity. But if I make this is high frequency. This is 8,400. Now, initially it doesn't feel much, but it starts feeling weird. It's still not feeling weird. You guys are pretty strong. Let's go to 14,000 and see. I think this thing doesn't play, I guess. So there, you can just download that app. There's an online, frequency generator on your app. It irritates you pretty well. You can irritate dogs. So if you have a lot of street dogs and you want to irritate them, you can use it. There's a chance they might come and bite you also. So that we don't know. So I hope you got the difference between frequency and intensity. Don't get confused. Frequency is how many waves you're hitting. That will irritate your eardrums because you're oscillating pretty fast. Intensity, whereas like how much you're stretching. Okay. Then so when you write your general wave equation, y is equal to a sine kx plus or minus omega t plus phi, it is still valid. Now remember, this is your property which we are studying. Ears are ringing a bit. So the equation would change like this. So delta P would be delta P max sine kx plus or minus omega t plus phi. We're just going to change everything. So this would be change in pressure. So you're not studying pressure, we are studying change in pressure. This is change in maximum pressure. What do you mean by that exactly? Let's say if there is no sound in the medium, the molecules are equally spaced. And the pressure in the region would be P naught 10 power 5 Newton per meter square. So when you propagate sound in the region, you will observe there are some regions they'll form a cluster, some regions they will expand, some regions they'll form a cluster. So at these positions here, this thing becomes P naught plus delta P. In this region, it is P naught minus delta P. Here again, it is P naught plus delta P. And this delta P is in the range of, so basically this is your compression. So here the change is positive change plus delta P. Here it is a negative change. So pressure can't become negative. Delta P can become negative. So here example, the delta P is in the range of 20 pascals, let's say. Delta P max is 20 pascals. So you won't get a huge change in pressure, meaning the pressure is changing like 1 lakh plus or minus 20. So the sound, what you're hearing is simply the 30, 40 pascals ka pressure difference is what you think is sound. So here if you see now, delta P can be positive or negative. Whereas pressure always has to be positive. There is no meaning of negative pressure. So that is the reason we are studying change. We are not studying pressure as such. I hope everyone is clear. So right now, the pressure outside is 10 power 5. The pressure inside your eardrum is also 10 power 5. So whenever I speak and the sound hits your eardrum, when the compression hits, you're hitting with the 10 power 5 plus 20, your eardrum will compress, meaning it will become like this. When the rarefaction hits, your eardrum will come outside like this. So your eardrum is continuously vibrating in and out. And you have a nerve endings there which generate electric signals based on this oscillation. Clear? Next thing. Now, let's see the relation between this. Equation derive karte hai na? We have a better equation than this. This thing I just wrote in general.
Okay.
The proof is not that important, but let's see, the result is important. So consider a region with bulk modulus B. So bulk modulus is minus dP by dV by V. Hope you remember this. So you consider a small region where this coordinate is x and this is x plus dx. So the particles at x, they displaced by y. The particles at x plus dx displaced by y plus dy. Remember, in a longitudinal wave, particles displace in the direction of the wave propagation, that is in the x. So the displacement of particles at x be y, and at x plus delta x be y plus delta y. And let area of cross section be S, because we're already using A for amplitude. Now, so if you look at the volume, so volume V will be S into delta x change in volume, delta V, will be S into delta Y. Agreed? Because see, this thing is moving Y and this thing is moving Y plus delta Y. So the change will be final minus initial, that will be S delta Y. If I substitute there, we end up with bulk modulus is equal to minus dP by dy by dx. This is the relation between pressure and the displacement, where y and x is an equation in displacement and this is the pressure. Quite a useful equation, right? Just like that Vp is equal to V wave dou by dou x. This is also pretty important equation. Gives you relation between pressure and displacement. Relation between change in pressure and displacement. So what is dP here? So dP is the change in pressure at x. Because of which the material got compressed by dx. Y is the displacement of the particle at x. So that's what I wrote. Clear? Now, if you remember our general equation, so y is equal to a sine kx minus omega t. Remember, y is displacement. So if you want to find pressure, dP is minus bulk modulus dou y by dou x. So if I differentiate this, you end up with minus BAK cos kx minus omega t. You can send the sign inside, you end up with BAK sine kx minus omega t minus 90. Means if you look at this, the dP and displacement are both are out of phase by 90 degrees. Means when the displacement is maximum, the pressure change is maximum. And you can look at this term here, BAK is the pressure amplitude. This is your delta P max. So let me write the final results here. So the maximum change in pressure in a region is bulk modulus amplitude into K. What is A? A is displacement amplitude, the maximum displacement of the particles from mean position. Now we have to be careful. We have to keep saying pressure amplitude, displacement amplitude. Because if I just say amplitude, you won't know which one I'm talking about. Transverse wave में वो problem नहीं था. Because we know it is always displacement, but in a sound wave, you can study both. So I will call it displacement amplitude, delta P is pressure amplitude. So this is change in pressure amplitude. That is a full name, but I'm lazy, so I'll just call it pressure amplitude. K is, your wave number 2 pi by lambda. That is 1. And this statement is important. Displacement and delta P are out of phase by 90. That means when displacement is max, delta P is minimum, and delta P is this thing that is maximum. But there's a trap there. So people generally think something. I'll show you with a question next time. So they are the main things there. So this is a relation, right? If this is your general displacement equation, this is a pressure equation. If you write this thing in terms of cost, this will be sine kx minus omega t. So if y changes, derivative changes. So exam they can ask this. They can give you this displacement thing and they can ask you find the pressure. Clear with this? So this is the proof. Like I said, proof is not important. That equation is more important. Okay, have a look at this. Take a break. Come back by 7:2. Any doubts? Anything that you're not clear so far? Okay, come back in 10 minutes. Yeah. So, Aditya, this y here na is what? Displacement of particles along x na. In longitudinal wave, the particles oscillate in the direction of the wave. So if you see how it is going, x coordinate is this way, y is also this way. Y is not y coordinate here. Y is simply displacement. In case of transverse wave, the y became y coordinate. Make sense? So y is the displacement of the particle from the mean position. Meaning from this mean position, this particle is oscillating left and right. So that distance is y. Is that fine, Aditya? Make sense?
So how do we represent the pressure difference?
Pressure difference dp. अरे dp is this thing ना. Previously it used to be p naught. अभी p naught plus dp हो गया. ये difference है ना. You're comparing pressure difference between not 2 points. You're comparing pressure difference with time. At the same point, before what was the pressure, now what was the pressure? Normally pressure कितना होना चाहिए if there is no sound? 10 power 5.
Yes.
When the sound is passing, sound became 10 power 5 plus 20. So what is dp? 20, na?
Yeah.
Understood what you're comparing? You're comparing the pressure at the same point at different times.
So in transverse wave, we used to represent the y direction, the amplitude.
Yeah.
So
Why was the amplitude?
So is
Bolo.
the pressure difference at a particular time constant?
In a transverse wave, there is no different discussion about pressure. Don't get confused.
No, so not in transverse, in sound waves.
Okay, in sound waves.
Is the pressure difference constant at a position at a particular x during a
नहीं ना,
particular time?
देखो ना, change हो रहा है ना. Here, it is changing with kx and omega t dp, where it is constant.
No, sir, at a particular given time and a given x.
हाँ, yeah. Value तो कुछ आएगा ना dp.
The pressure difference is constant.
नहीं, you can't say that. When you say constant, meaning when you say something is constant, it does not change with time. उसको constant बोलते हैं.
Okay.
But if you put time constant, if it's constant, तो there is no meaning of it. It's like asking v is equal to t square plus 2 cube. Is v changing?
Yes.
But a t is equal to 1, v changing doesn't make sense, isn't it? Anything that changes with time is called a variable. So don't put time ka value there. All clear with this? And let's see a question. The question which I goofed up when I went for interview in 2010. Job interview for a teacher. And they asked me this question, I goofed up and came. But I still got selected though. They asked me 10 questions, I could answer 4. I just passed out now and I was so hopeless, I felt really depressed and I was walking away from there. Interview ke baad. And the principal there called me. I said, what happened? I said, I got only 4 out of 10. I don't think I'm fit to be a teacher here. I'm going karke, I'm leaving. He said, hey, come back here. Pagal ho gaya kya? He said, other people got only 2. You have got 4. You're the second. No problem karke. And that person is also from IIT Madras. He was working as a teacher from 10 years. So he was my senior in IIT 10 years back. So then they hired me as a 4th teacher. So in that campus, we used to have 3 teachers. I was a 4th. So senior teachers were 2 and we both were hired there. So that is where I got trained in Hyderabad. So it used to be they used to select all the students from Andhra Pradesh. It's a batch of only 45 kids. Bus, 6th floor campus, 45 kids in 11th, 45 kids in 12th. 45 kids ka out of 360 na, the least score used to be 310. Least score is, that is the last ranker ka score tha wo. Every year we used to get 20 ranks in top 100. Obviously, out of 2 lakh people, they selected the students, they picked each and every one and they trained them. So complete AC campus, everything free. Those kids, everything is free. And if you get they used to have offers also. If you get a first rank, they will get 1 crore. You guys know, na? Pata nahi? People do get offers. So when these people go and hire them to take the students, na, they get an offer like this. For now, take 2 lakhs ka advance. And this is the offer. If your kid gets first rank, we will give him 1 crore. If he gets in top 10, he will get 25 lakhs. The offer ye tha. So because of this, there used to be kidnapping of kids. वो अलग level था. And I used to work in Chaitanya. And दूसरा competitor था Narayana, which you guys know both, which came here. So these two people used to be competitors. So kids used to be kidnapped from here to here, from here to here. It used to be अलग ही racket चलता था वो. Kidnap मतलब parents know. So what this Narayana used to do, the Narayana used to go to the parents and say, Chaitanya offer kitna kiya? 1 crore, we'll offer 2 crores. Now again, 2 crores is when if he gets the first rank. If he gets the first rank, that condition is always the same. Everyone doesn't get that money. So एक को ही मिलेगा. So the parents used to call the kid and say, during break time, na, so and so van number will come, 7314 whatever. Get into that van. वो movies पे दिखाते हैं ना, that Omni van comes, door opens and they kidnap and they drag them. Something like that. So evening 5 to 6 we give a break. So the kid goes out walking and he never comes back. So one day ऐसा ही हुआ था. I was in the second year that time. One kid was missing. 6 o'clock हो गया. One guy was missing. We started searching. I was damn sure he must be sleeping under the bed somewhere in the hostel. So we are searching everywhere in the rooms. Evening 8 ho gaya, we couldn't find him. Then we thought he must have gone to a movie. Kabhi kabhi hota hai. When you are frustrated so much, they just leave the campus, go to the movie and come in the night. So we went to the movie theaters and we are searching for him there. Night 12 ho gaya. We couldn't find him. Now we got tensed. We said, yaar, abhi parents ko to inform karna padega. Hostel campus tha. So at night 2 o'clock, we called the parents. And we told them, ma'am, your kid was missing from evening 5 o'clock se nahi dikh raha hai. No, sir, हमने क्या है ना, we shifted to Narayana. Parents is so casual, yeah. हम पागल जैसा 6 घंटा भाग रहा था रोड पे. We shifted to Narayana, so no problem करके puts the phone, हाँ. कुछ नहीं है मतलब. So yeah, I studied in Narayana. I worked in Chaitanya. Both of them are like अलग ही level है. It's a factory there. Anyways. So Y and X, but it was a pretty solid campus, right? Tell that only. Someone wants to become a teacher now, should go to that campus and work for 2 years. You learn a lot. So we have a YX graph here. Now remember, be careful here. YX is a longitudinal wave. So YX graph of now this is not the trajectory. This is not the photograph. Meaning, if the particle is going this way, wave is going to the right, the particle is oscillating y is this way. Be very careful. There is a high chance you'll get confused between transverse and this. So the question is, so we have a point A here, we have a point B here, we have a point C here, we have a point D here. So which point has maximum pressure and minimum pressure? Or I can ask you, arrange the pressure at A, B, C, D in ascending order. Which points have maximum and minimum pressure? It's a good question. Give it a try. So I gave you a displacement versus X graph and I'm asking you to find the pressure. Shan is asking, sir, salary kitna loge? That also actually happened. Interesting, huh? End mein salary ka discussion aaya tha. He said, how much you want? I told him, sir, I'm earning X. Right now, you give me X and we'll find that. He said, I'll give you X plus 10,000. He only increases salary and he said, you don't even know how to discuss the salary, idiot karke. That is the best thing. When your senior is your own IIT ka senior, na, he will make sure to get the best for you. In that sense, I was very lucky to get good teachers who can teach me. Let's get this. Maximum pressure. C has max pressure. A has min pressure. Okay. Max pressure at B. Now, if you go back to that thing there, remember the formula we derived just now? This was a mistake I did. dP is minus bulk modulus dou y by dou x. So if you look at point A and B, so at B and D, slope is 0. That means the pressure at B and D, delta P is 0. Now, this is where a mistake I did. I didn't say delta P. I was just saying PPP karke. And at PA, so this is a change in pressure. So at B and D, dP is 0. This means pressure at B and pressure at D was P naught. समझ में आ रहा है? Pressure 0 नहीं था. Change in pressure was 0. If there was no sound wave, the pressure would have been P naught. So at B and D, there was no pressure change. Now, if you look at A, the pressure dP was minus bulk modulus and the slope is maximum slope. So this is a positive max slope. That means at A, the dP max is a negative maximum. This is a max negative change. That means pressure at A is P naught minus delta P max. Getting the thing? So this was a mistake, you know. When I said both of them are out of phase by 90 degrees, when displacement is maximum, delta P is minimum. When displacement is 0, delta P is maximum. But I didn't tell you whether it's a positive maximum or negative maximum. Are you getting the difference? Similarly, at C, dP would be negative and slope is also negative. I mean, this is a positive thing. So pressure at C would be P naught plus delta P maximum. So don't get confused between pressure and change in pressure. Look at the word here. Which points have maximum and minimum pressure? I'll do one thing. Let me add another question. So that will give you more clarity. Which points have max change in pressure? I think now I hope you're getting the difference. Let's say you went from 100 to 102. You went from 100 to 98. What is the maximum change? Both are same, right? But what is the maximum value? 102, right? Are you getting the difference between maximum change in pressure and what pressure at a point? So if you look at the answer here, the order would be what? Pressure at C is the greater than pressure at B and pressure at D are equal, and then pressure at A. Where is the maximum change in pressure occurs at C and A? That way. One is a positive change, one is a negative change. Is this making sense? Now, this question, right, when I teach medical people, I don't teach this way. I give them more simpler form. There is a more intuitive way of doing it. Turning the page. Any doubts on this? Palaksh, clear with this? Malika? Understood. Neil, Lakshika, Vartika, clear? Now, the other way, alternate way. Now, let's try to understand. This is nothing but displacement here. So this is the displacement of different molecules. So if I consider a molecule here, if I consider a molecule here and I consider a molecule here, meaning at point A, consider one molecule before you, one molecule behind you. So this molecule, cut displacement is what? This is Y is positive. Means how is the particle going? Away from this way, right? Remember, Y is the displacement along the wave propagation. If you take 1 point behind, Y is negative, meaning the point behind you is going backward. Now you tell me, if the particles are going away from that point, is it expanding or compressing? Expanding, right? So this is a rare fraction. So pressure at A is least. Same logic, try to apply at this point and see. At point C. So if I take a point here, the displacement Y is negative. The point behind you, Y is positive. That means exactly at C, if you take the point in front of you and point behind you, the point behind you is coming towards you, the point in front of you is coming back to you. This is compression. So here, PC is max, PA is minimum. So this way, intuitively, you can figure out without using any max. You just look at the particle in front of you, particle behind you. If they're coming towards you, you're compressing. If they're going away from you, they're expanding. So the pressure is less. And if you look at B here, you can clearly see something here. The guy in front of you and the guy behind you both are traveling same distance. So what will be the length of that piece? Same, right? Volume is, there's no change in volume. That's why the pressure at B and D doesn't change. So here, observe the molecules in front and behind point A and C. This is a more intuitive way. In case by chance you couldn't figure out this formula, you forgot, this will always help. So when they ask this question now, I told the answer for the second question. So be careful with that. That word will change a lot. Maximum change in pressure is different. Maximum pressure is different. All clear? Next thing. Next one. This is a good one. You can put a star for this question. It is, especially this formula makes it pretty nice. 31. Speed of the sound wave is 330 meters per second. The frequency is given by 16.5 hertz. Amplitude is 2 millimeter. You can look at the dimensions as displacement amplitude. Difference between max and minimum pressure in a region is 20 pascals. Find bulk modulus. It is just all formula substitution. Let's give it a try. Just write the equations and leave it. Numbers might be bad. ऐसा ही दे दिया. फिर भी I tried my best. But let's nothing. Just formula substitution. What are all the formulas? So you want bulk modulus. So just remember all the formulas you have. Delta P max is BAK. A is given. I need to find K. I know V wave is omega by K. So K is omega and omega is 2 pi F by V wave. So this is 2 pi 16.5 and this is 330. So that would be 33. So pi by 10. K का value आ गया. Amplitude दे दिया. What is delta P max? So done. If I got that, I got everything actually. So delta P max, I need to find. Amplitude is given. K ka value I know. What is delta P max?
So 10 pascals.
It's not 20. Be careful. I said the difference between maximum and minimum pressure. So maximum, so P max minus P minimum is 20 pascals. So P max will be P naught plus delta P max. So P max and delta P max are different. Huh? P naught minus delta P max. So delta P max will be 10. So be careful. 20 dal diya na, you'll be gone. I didn't say the maximum change in pressure is 20. So this is 10 and A is 2 mm. So 2 into 10 power minus 3 and this is pi by 10. So you'll get the answer from there. Easy? That's it. That was the main trap. That P max minus P minimum is 20 pascals. Baki sab theek tha. Next one. Next one. Speed of a longitudinal wave. We'll not be doing the proof for this. It's not a big one, but it is not important. We're not doing for a sound wave, we're doing for longitudinal wave. That is even more general than sound wave. So V longitudinal is given by root over bulk modulus by rho. Now this is for a waves in a fluid, 3D waves basically. Basically, you can say in 3 dimension it travels. But suppose if the fluid or 3-dimensional waves. Let's say if you're talking about waves in a rods. Now in a rod, there's no meaning of bulk modulus for thin rods. The formula becomes root over Young's modulus by rho. B is your bulk modulus. The rho is your volume density, not mu. And Y is your Young's modulus. You should definitely mark up these results. So when I say longitudinal wave, it need not be a sound wave. I can take a rod and hit it and you can get a wave in that also. Do note them down. Let me show you how they can frame a question on this. Turning the page. Yes, example. Let's say we have a rod like this. You take a hammer like this and you beat it like this. You hit it vertically. Then what will happen? You will get a bump like this. What kind of wave is this? This is a transverse wave. Because the bump is traveling up and down. And we know V transverse is root over T by mu. The same rod take the hammer like this and you beat it like this. This time you'll get a bulge like this. You're getting how is the bulge traveling? It's compression and going. I showed you that क्या था वो slinky. So in this thing, if you see here, the displacement is up and down. Here the displacement is right and left. So this is V longitudinal. So that means on the same rod, depending on how you are hitting, I can generate both types of waves. So in this V longitudinal is Young's modulus by rho. So if I take the ratio of this, so V transverse by V longitudinal is a root over T by mu and Young's modulus by rho. And I can write the Young's modulus, the formula you remember, tension length by A delta L. So this guy would become so tension by Y becomes A delta L by L and rho by mu. And I hope you remember again, rho is nothing but mu by A because mass per unit length into density. So that will get cancelled out actually. So you'll end up with root over delta L by L, which is root over strain. This itself is a question. The ratio of a transverse wave in a medium and the ratio of a longitudinal in a medium is root over strain. And both will travel with different speeds. In case of earthquakes, there is something called a P wave and S wave. So whenever earthquakes are generated, you get both transverse wave and longitudinal wave. So this is what happens. Let's say whenever there is an earthquake, it generates both the kind of waves. So there is one transverse wave which is traveling and there's one longitudinal wave which is traveling. Since both have different speeds, they will reach at different times. If you look at here, strain is generally less than 1. So longitudinal waves will reach first. After some time, the transverse will hit the ground. That means when you're getting an earthquake, first you'll see some shaking, then comes the second wave. There's a difference in time delay. Based on this difference in time, I can calculate at what point the earthquake started. That is what we call as epicenter, the point of origination of earthquake. And this is actually the concept which we use to study the earth ka core. Kabhi socha apne, how do people tell you like at a distance of 100 kilometers, earth ka crust is like this, core is like this? We don't have any information. No one actually digs that deep and sees. The only way we can study the surface ka earth crust and all is using this phenomena. You send different waves, and when they reflect and come back, you see the difference in speeds, and from there you try to figure out what kind of materials and densities are there. It's a pretty good result. So in earthquakes, we call it P waves and S waves. This is how you can play around with this. Next one. Next time. Now, how do you find the speed of sound? So the first guy to try is, as usual, our Newton. Is there everywhere? Yeah, maybe he's a time traveler, I guess. He must have taken a physics book and must have gone back to the past. In सब जगह नाम change कर लिया. Could be a possibility. Or they say the story, that Apple story, you should have sat under a coconut tree. खत्म हो जाता the story उसी दिन. Because of that bloody apple, we are getting so many theories. If it is a coconut tree, the story would have been ended that day. Anyways, but actually, right? The place where Newton said there were no apple trees. That was just a fake story to make it more interesting. When Newton was studying in the university, there was a plague, like COVID. University ko holidays de diya tha. They said, all get out from here and go to your house and you die there. Don't die in the university. So people went back to their homes and Newton was just sitting at home, bored for months and months. And that is when he started seeing objects and all. The apple was just a thing. There were no apple trees in the place where he was staying. That story was nonsense, but still, coconut tree would be interesting. Anyways, jackfruit tree bhi chalega. Ever seen the size of a jackfruit? Now, this is what Newton ka theory, what is what I proposed. He said, since sound propagates in atmosphere, and the temperature of the atmosphere is relatively constant, it doesn't change. And temperature is constant. So he assumed propagation of sound is an isothermal process. Now, think about it. When the sound is propagating, the gas is compressing and expanding, isn't it? So it's kind of some kind of a process. He assumed the propagation of sound is an isothermal process. Not a bad assumption. Now we know isothermal process PV is equal to constant. We have done this in elasticity, if you remember. So the bulk modulus will be PdV differentiated on both sides plus VdP is equal to 0. So from here we get bulk modulus is equal to minus dP by dV by V is equal to P. Now applying the formula in the velocity of sound, root over B by rho. So the bulk modulus for an isothermal process is P by rho. And from ideal gas equation, we know P is equal to P by rho is equal to RT by molecular weight. I hope everyone knows that. So this thing comes out to be RT by molecular weight. And when he calculated this value, this thing turned to around 280 meters per second. And experimentally, this was wrong. The sound speed was around 330. So there was an error. Experimentally, this value didn't match. So somewhere this guy went wrong. But it was not a bad assumption as such. So this is the Newton speed of sound. Then after this, the guy came Laplace. He said, the sound is propagating so fast. When you say frequency of 1000 hertz, what does it mean? This gas is compressing and expanding 1000 times per second. So the compression is happening so fast, you're not giving enough time for heat exchange. So if you're not giving enough time for heat exchange, the delta Q is 0. What kind of process is this? Adiabatic. So we call this thing Laplace correction. Since gas compresses and expands pretty fast, when you say 100 hertz, meaning you're doing 100 times per second, it's pretty fast. The system doesn't have enough time for heat exchange. The compression and expansion happens so fast, there is no time for heat exchange. Therefore, it's an adiabatic process. So adiabatic process, PV per gamma is constant. Differentiate on both sides. Then you end up with bulk modulus is minus dP by dV by V is gamma P. So the velocity of the sound is root over B by rho. This turns out to be gamma P by rho, which is root over gamma RT by molecular weight. And this value works out. This gives you around 330 meters per second, which works out with the experiment. When you say frequency of the wave is low, how low are we talking about? Then heat exchange might happen and the thing might go off. Let's say even if you say 2 hertz per second, that is still pretty fast, right? Every half second you're compressing and expanding. It is still fast. But if you take a wave even lesser than that, then it is gone. The wave will dissipate literally. Nothing will happen. Nothing will work. I agree with you. But if you see, right, even when you speak and say ha, only that itself will generate almost 50, 60 hertz. Be careful here. Gamma is your adiabatic constant. Hope you remember. This is molecular weight in kgs. And gamma is 1 plus 2 by F. F is degrees of freedom. temperature should be in Kelvin, R is your gas constant. There, this is the velocity of sound in air or in a gas. But if they ask you velocity of sound in water, then use bulk modulus by rho. You can't use gamma RT by M. There is no gamma for water. This is for gases. Have a look at this. Yeah, let's see a question. Let's see a question. Two moles of helium and 3 moles of hydrogen are mixed at 300 Kelvin. Find the speed of sound. Easy one, straightforward. So it's a mixture. This is the formula, root gamma RT by M. Gamma is adiabatic constant. Try. What is the formula for F average? Good question. N1 F1 plus N2 F2 by N1 plus N2. Remember, never do this. Gamma average N1 gamma 1 plus N2 gamma 2 by N1 plus N2. This is a blunder. Never use gamma average. Gamma is not a linear function. Degrees of freedom is a linear function. So always have to find F average and then find gamma from there. This we have done in thermodynamics. I told you there. Try. Give it a try. You got a minute. Easy one. Straightforward question. So F average would be 2. Helium is 3. 3. Hydrogen is 5 by 2 plus 3 is 5. 621 by 5. You also have to find molecular weight ka average. That is again N1, M1 plus N2. That is 2. Helium is 4. 3. Hydrogen is 2 by 2 plus 3. 14 by 5. This is grams. So 14 by 5, 10 power minus 3 kg per mole. Be careful. Always should be in this thing. F average 6 hai kya? 2 into 3, 3 into 5, 15 plus.
I got same only.
Come again. Okay.
I got same as you.
So gamma average will be 1 plus 2 by F average. You should use this one for gamma average. Then ho gaya na? Substitute everything, you'll get the answer. I will leave it to you. Root over gamma, you know the value. R, you know the value. Temperature is 300 Kelvin and you know molecular weight in kgs. So just dump it there, you'll get an answer. Easy. Main thing is that finding F average, it's this part is mostly thermodynamics. So speed of sound in mixture of gases. You have to take molecular weight average and you have to take gamma average. Next one. Turn in the page. Any doubts on this, please ask. Let's do something a little better. So we have x is equal to 0. We have x is equal to 100 meters. At this region, the temperature is 100 Kelvin. At this point, the temperature is 300 Kelvin. So temperature varies linearly from 0 to 100. Meaning as you go from 0 to 100, temperature linearly increases from 100 to 300. The temperature is not constant. Temperature varies linearly from x is equal to 0 to x is equal to 100 meters, from 100 Kelvin to 300 Kelvin. Now, in this process, someone sent a sound wave here. And this entire region is filled with helium gas. Are you getting? So the entire region ka temperature is not constant. As you go from left to right, temperature is increasing. Find the time taken for the sound to reach the other end. So if you send a pulse from x is equal to 0, and how much time will you reach x is equal to 100? Means in the formula gamma RT by M, T is not constant. So you get a variable speed of sound. Let's try this. You got a pretty interesting thing. Try. I'll give you 2-3 minutes. Just give it a try. Temperature. Take it like that. T is equal to ax plus b. That is the meaning of a linear function. So when x is 0, T is 100. When x is 100, T is 300. हो गया ना? Two equations, two variables. You'll get it. So first you need to find temperature as function of x coordinate. So T is equal to ax plus b. If x is equal to 0, T is 100. This is equal to b. A will be 2. So therefore, we are getting temperature is equal to 2x plus 100. Got this? That's your temperature as function of x coordinate. Velocity of sound will be root over gamma RT by M. So in this, everything is constant except that T. Now what to do? So this can be written as dx by dt. This gamma R by M is anyway constant. Take out the 2 also. So 2 gamma R by M root over x plus 50. So this would be dx by root over x plus 50 is root over 2 gamma r by m dt. This will go from 0 to t. This will go from 0 to 100. Solve this, you will get the time. But there's a better way. Let me show you this. I'll turn the page again. So velocity of sound, you got root over gamma r by m. You got 2x plus 100. Square it on both sides. You'll get v square 2 gamma r by m x plus 100 gamma r by m. So if I just rearrange this, can you notice something? This looks like v square is u square is 2as. This is a constant acceleration. You can do the dv by dt karke dekho, you'll get constant value. So if you look at here, you are getting a is equal to gamma r by m. This is your constant acceleration. That means the sound wave is traveling with acceleration. At least the sound will think it is accelerating because the temperature is changing. This m is molecular weight. And that u is your initial speed. So this whole thing has become a kinematics question. A particle is starting with this speed, with this acceleration, find the time taken to the other side. I can use s is equal to ut plus half at square and I'll get it. You can skip integration, but they could also ask you what is the acceleration of the sound wave. So here, since the temperature is changing, the sound wave accelerates. Do you remember this thing where we did something, that rope hanging wala question? There also something similar happened because there also tension was changing linearly, same thing happened. So the ideas were same. Here temperature is changing linearly, their tension was changing linearly. There it was root over t by mu. Here it is root over temperature by mm. Everything is same. Mathematically, they look exactly the same. Only thing, this is sound and that is a wave on a string. There, you could have integrated any day. But I want you to realize that acceleration is also constant. Any doubts on this? All clear with this? Next one. Next one. So variation of sound with pressure, temperature, and humidity. This is a pretty good bits or a main level question. So what happens with pressure? Variation pressure. So if you look at this V sound, so tell me one thing. If the pressure becomes 4 times, what will happen to the sound? So gamma P by rho, which we write it as gamma RT by M. So the most common mistake now, what people think, if pressure increases, sound speed increases. What people forget, we know P by rho is equal to RT by molecular weight. If P increases, rho also increases. If you increase the pressure, gas will compress, increase the density. So P is just not an independent variable. And P by rho remains constant. So velocity of sound depends only on temperature. So be careful. Just because you see a root P in the numerator, don't think it will depend on pressure. This speed of sound is independent of pressure. No matter how much pressure you increase, the rho will also increase to compensate and depends only on temperature. This was a straightforward bits question. They would say like this only, the pressure became 4 times. What happens to speed of sound? Nothing happens. People will write 2 times and come in a hurry. So be careful. Next thing, with increase in humidity. Again, what is humidity? You are replacing air molecules with water molecules. What is the molecular density of air? Nitrogen almost 28. Water is 18. So you're replacing air molecules with 18 molecular weight. So m is decreasing. The speed of sound increases. So when the water has more humidity or more water molecules, the speed of sound is more. In an extreme case, when all the air becomes water, what happens? Obviously, sound travels faster in liquids. That's an extreme case. You're replacing air molecules whose molecular weight would be around 28. With water molecules whose molecular weight is 18. Therefore, the m in the denominator decreases, so v increases. So if you increase the humidity, sound travels faster. So during night, winter, when there's a lot of fog and all, and when you shout, the sound travels very fast. Clear with this? So that's an important statement. It is independent of pressure. Next thing, echo. So what's an echo? When a sound wave encounters an obstacle, the reflected sound is called an echo. Sound rate obeys vector, laws of reflection and refraction. We discussed this in ray optics. So if a sound wave hits the wall, it bounces off just like a light ray. And the same thing, let's say if a sound is going from water to air. So if you see for water, sound travels faster here. So it's a rarer medium. Sound travels slower here, so that's a denser medium. So if the speed is more, it's called rarer medium. If speed is less, it's a denser medium. It's based on that. It's not on your regular density. So if you send a sound wave from air to water or water to air, so when you're going from rarer to denser, what should happen? Let's go reverse. When you go from denser to rarer, what should happen? Should go away from the normal. But if it was a light wave, it would have been a reverse. So the sound would be like this. Light would have behaved differently. Light would have traveled like this. It would have come closer to the normal. So this will go opposite to light. So Snell's law is valid here. If you take this is I and this is R, mu1 sin I is mu2 sin R, where mu1 by mu2, if you remember, it is the speed of light. So this is the speed of sound. In water by speed of sound in air. Because if you remember, refractive index is defined as this way. speed in vacuum by speed in medium. So mu is proportional to 1 by speed in medium. It will be inverse proportional. So if I can write this thing, I'll do one thing, but I'll write this thing as this only. So mu of air, this is mu of water. So mu of air by mu of water, you can define like this. Because see, tell me one thing, mathematically, does the max care whether you're talking about a light wave or a sound wave? It doesn't care. How did you define refractive index? It is a ratio of two speeds. Max will think water is vacuum here because it's going faster, and the air is like a medium because it's going slower. Are you getting the relation? You can just convert the whole thing to a sound wave to Snell's law and it works. Clear with this? So they can play with sound waves like this also using ray optics. So be careful with that. Okay, put it down. So next class when we catch up, we will do maybe a problem on this and one or two problems on echo, and then we'll go ahead with intensity. Then we have this thing, what do you call decibels. We'll study about decibels, and then we'll start off with stationary waves in a sound waves, organ pipes. That would be another important one. Till now we did stationary waves on a string. Idea will be exactly similar. Only thing we'll talk about pressure and stuff. Mostly we should be able to finish off in the next class that one, and then we'll start off with beats and Doppler. I think another 2.5 classes max, we should wrap up the chapter. Because the starting part which you take, right, that took a lot of time. Like we did properly, like what is an equation and all. So here there's no need to do that equation and everything. That equation itself took us time. Anyway, so we have done but almost how many problems? 33 problems. So do make sure to go through this, right? In case you're doing HCV or something, you can start doing the first chapter. There are two chapters in HCV, waves on a string and waves on this thing. Even if you're doing DC Pandey, there are two chapters, waves on a string and waves on this thing separately, I guess. So whatever material you're doing, at least finish off waves on a string part properly. So, okay, so with that, we'll wrap up for the day. So there is a test online till tomorrow. So make sure to give. There is a deadline, gravitation. So any doubts, anything in today's class, anything else, you can stay back and ask. Also free to leave. And people, others who didn't fill the form, please fill it up. Do make sure to